Hello and welcome to Team 2168's 2020 Intro to Java lessons. These lessons are based off of our previous head coach, Kevin Harrell's older lessons from years and years ago. This year, our programming subteam decided to adapt his lessons to reflect changes in WPILib. That being said, although these lessons were made for an FRC team, most of them are about Java in general, so regardless of whether you're on a FIRST robotics team, they'll be a useful resource for learning about programming and specifically Java. We're making these publicly available because our previous lessons were, and these can probably help a lot of people, so that's part of why I'm recording these videos. I'm also recording them as a reference for future students on our team for how these lessons should be taught, so hopefully some of you watching are 2168 students. Anyway, I should probably introduce myself. I'm Sierra. I'm 2168's team captain and robot systems sublead for the 2021 season. I also used to be the programming lead before being promoted to team captain, so I helped out a lot with adapting these lessons. But enough with personal introductions, let's get into the introduction of Java, Lesson 1. Oh, and as a side note, we'll be using VS Code as the integrated development environment, or the program that we write code in, for these tutorials. Obviously, you don't have to use VS Code, but I will be including the link to the WPILib version, as well as to the normal version, in the description, so if you want to install it, check out one of those links. Anyway, what is Java? Java is a programming language. Programming languages are a specific kind of constructed languages designed to be written by humans and executed by computers. They are languages that humans can use to tell a computer, a machine, what to do. Why do we have programming languages? Computers need to be told what to do. A computer program is a set of instructions for the computer to execute in a particular order. Digital computers are designed to only understand instructions of zeros and ones. This is called machine language. However, writing these instructions is naturally very hard for humans to do. So modern programming languages were developed which are a lot easier for humans to write. These are called high-level languages. And then here's an example of this same code, but in a high-level language, Java. Computers can't read high-level languages. Since computers only understand zeros and ones, but humans want to write instructions using words, we need some way to convert the text instructions that humans understand to the zeros and ones that computers understand. Programs called compilers were developed to convert the higher-level languages into zeros and ones. In order to execute your code, you need to compile it first. So compilers act as the translators between the HLL and the machine language. Problems with compiling. Compilers translate your code to machine code directly for one processor architecture only. If you were a developer and wanted to share your code with the world, you would need to compile your code for every possible architecture. That would obviously become very time-consuming, especially when code is updated and everything needs to be recompiled for each architecture. This is how another high-level language, C++, works. So every time you make a change to your code, you would need to recompile it for every single type of architecture. How is Java different? It's pretty ingenious. Java doesn't compile directly into machine code. Instead, Java compilers translate your high-level code into something called bytecode. Bytecode is the machine language for a fake virtual computer made up by the Java developers called the Java Virtual Machine. If you've ever used a virtual machine, you know what it is. It's exactly what it sounds like, a virtual computer, a machine within your machine. So in this case, it's just a virtual computer that has its own native machine language that makes it easier for you to translate this code into each different processor architecture type machine code. So the Java bytecode is then translated to machine code by a program called an interpreter. So here's a nifty diagram of the process. You have the source code, which is written in Java, the high-level language that humans can understand. Then the compiler will translate that into bytecode, which is the language of the Java virtual machine. Then each different type of machine has the Java virtual machine on it, so that it can interpret the bytecode and translate it into the native machine code of whatever device it's on. The Java interpreter is called the Java virtual machine, as we have talked about. It lives on the target, so that being the desktop, the robot, whatever device. Its job is to convert the bytecode into machine code for the computer of the device it is on. The Java virtual machine interprets each line of code, so this means that it converts one line of bytecode to machine code. It then executes that machine code, and then it moves on to the next line, converts it, etc. The cycle continues for each line of bytecode until the program is complete. So it goes one line at a time. This makes Java code very portable, having the JVM, because after you compile the Java code into bytecode, you can run it on any machine that has a JVM. It makes it a lot easier than having to recompile it every time for each different architecture. Why do we use Java for robotics? So this is specific to our team. We use Java on the robot for the reasons outlined on this slide. Today, there are literally thousands of different programming languages to choose from, each having their own pros and cons, and varying difficulties of learning. There are high-level languages like C++, C#, Python, Perl, Ada, Fortran, etc. And then there are low-level languages, which are assembly languages. It varies for each processor. The reason we choose to use Java is simple. As of today, Java is one of the #1 taught languages at universities, so we use Java in hopes that you'll learn enough to prepare for college and for the future. Right now, Python is becoming a lot more widespread and popular for being taught, but we also do use Python on our team for our side projects. So being able to learn Java and Python, depending on what you work on, gives you a good range of knowledge of different programming languages. The majority of other FRC teams use Java, C++, LabVIEW, or Python. So the remainder of these courses will focus on Java, obviously, as it applies to developing code for robots competing in the first robotics competition. So, although it says that, most of the lessons are just about Java in general, and then it becomes more focused on robot code around lesson 6. So, if you're not on a first robotics team, you can stay tuned for a while. But now, we're going to write our first Java program. So the only way to learn Java is to jump right in. So I'm going to switch over to VS Code, and I'm then going to go to File, Open Folder. This will bring up a prompt where you can navigate to a directory. I would suggest creating a new folder in your documents called something like Java Lessons, for you to store all of the Java files in that we'll be creating throughout the lessons. I have a folder called 2020 Lessons that I'm going to open. So then VS Code will load up the folder, and it'll appear in the Explorer panel. So it will now allow you to create files or folders within this directory that you opened. So what we want to do is to create a new file called My First Program. It's also worth noting that it's convention to write file names with each new word beginning with a capital letter. We'll talk more about naming convention later, but you should be titling it exactly like this. And then if we just press enter right now, it'll just become a text file. but we want it to be a Java file so that it will run code. So in order to do that, we need to add the file extension at the end. So we need to type .java, and then you'll see that the icon changes, letting us know that it's now a Java file. And then if you press enter, it will create the file with that name. So we now have myfirstprogram.java. Now we're going to type some code, and I'll explain what the code does afterwards. But first you'll want to type public class myFirstProgram, and then you'll want to use curly brackets, which look like that. Then write public static void main, open parentheses, and you'll notice that VS Code, when you create a bracket or a parenthesis or a quotation mark, it'll automatically close them for you. So that's one of the benefits of using an IDE. Many of them will automatically close parentheses or brackets. So within these parentheses, you'll then want to write string with a capital S and then square brackets, args, A-R-G-S, and then at the end of the line, use a curly bracket. And then finally, write system with a capital S dot out dot println, open parentheses, open quotation marks, hello world, and then at the end of the line, put a semicolon. So this right here is what's called a hello world program. What it does is when you run it, it'll print something out to the console here. As you can see down here, it says hello world. So this is like the default program that most people write when they're learning how to program for the first time, or when they're learning how to write in a new programming language. So if you learn some more languages, you'll probably be seeing this type of program a lot. Now back to the slides. Java program structure. So every Java program contains a class. Public class myFirstProgram. So in this case, this is how we created the class. This is the class header. It includes the name, and then these other words right here, public class. Then within the curly brackets is the class body, where the code that will actually be executed is written. And right here is an example of a comment. So a comment is something that can be placed almost anywhere, and we'll talk about them a little later. But essentially, if you write 2 forward slashes, this is a comment. And it just does absolutely nothing, so it won't interfere with your code. If we run it again, the same output occurs. It still says hello world. This is just here to function as like a note for the programmer. But again, we'll talk more about comments a little bit later. So within the class, we have the main method. So you can also have some more comments about the method. This right here is the method header, so it's a similar structure to a class. And once again, within the curly brackets is the body, in this case the method body, where code that actually happens is written. So you see this comment that says do stuff. So again, this is the main method. It's called main. The main method is where your program starts. Every program must have a main method defined somewhere, and its header must be written exactly as above. So it needs to be called main, and all of these other words and symbols need to be there. The main method is where the code begins running when you run a program. Now let's break it down a little further. So a Java program always contains a class definition, whatever that means. We'll talk more about classes later on down the line, with a method named main. When the program is called to run, the main method is invoked, meaning the actions specified by the main method are carried out. So if you write code that does something in the main method, then when the program is run, that code that you wrote in the main method is executed. The body of the main method is enclosed in brackets. These are curly brackets, so that when the program runs, the statements between the brackets are executed, as I was just explaining. Every Java statement is ended with a semicolon. This tells Java that the line is done and to move forward to the next one. So it's very similar to a period in English. It just tells you that the sentence is over. So with Java, the semicolon tells the computer that that command, that line, is finished. If you're not familiar with the words class and method, don't worry, they will be explained soon. So this line is the first line that we wrote. It says that the program is called my first program. So when you create the class header, it needs to have the same name as the file. Then the next two lines, as shown below, are the definition of the main method. So we have public static void main string args, as we wrote. This is the method header, and it defines the main method. The details of exactly what a class is and what words like public, static, void, and so on mean will be explained in detail later on. But until then, you can think of these lines as a rather wordy way of saying, begin the program named my first program. So once again, every single Java program needs to have at least one class with a main method. So there can only be one main method, but you can have multiple classes. But again, you don't need to worry about that too much, and for a while we'll only be working with one class. The following line is a print statement, so you can see it says print right here. So whatever is in the parentheses is printed or displayed in the terminal. So if we go back to VS Code, once again, when we ran this program, it wrote the words hello world down in the terminal. Hopefully it's not too small for you to see, but if you run the program, you'll see the same thing in the terminal. It says hello world. So again, whatever you put in the parentheses here is printed or displayed in the terminal. So that's what a print statement does. Another example would be if you print, my name is Kevin. So if you were to write that, then the terminal would instead say, my name is Kevin. This is just an example of a simple program. This one would be called firstprogram.java. So you can see that they have the class, and then the curly brackets, then the main method here with the same structure of this first line, and then more curly brackets, more print statements, and then some other arithmetic type things that you have not learned yet. But as you can see, what was written here in the print statements gets printed to the console. Hello reader and welcome to Java. You can also see that in this example, the curly brackets are on a different line. So it doesn't really actually matter what line the curly bracket is on. You could start it on the next line, but our team likes to keep it in the same line as the header. It's just convention. So if you're on our team, that's how we will be doing it, but other people might use other conventions. So it doesn't really matter. It won't affect how the code is run. It's just a stylistic thing. Alright, it's time to learn about arithmetic. So Java can do math, and it allows for all of the standard math operations. So we have addition, subtraction, multiplication, and division. And it can also do more complex calculations and follows the standard rules of PEMDAS. So you can use parentheses to control how a statement is evaluated. So for right now, we're going to write this in my first program. So back to VS Code. We'll do some math now. So we're going to write some more print statements, just like what that image showed. System.out.println. And then we're going to do 3 plus 3. This is addition. So again, here's a comment. This doesn't influence the code, it's just a note to the programmer. So now we know this is addition. Then system.out.println 3 minus 3. And that's going to be subtraction. Then we have, you guessed it, system.out.println 3 times 3. And multiplication is denoted by the asterisk in Java and most programming languages. So this is multiplication. And then system.out.println 3 divided by 3. So division is denoted by a /, and this is division. Alright, so if we save and then run this, now it's going to print out to the console the solutions to these arithmetic problems. So it's not going to print 3 and then the plus symbol and then 3, but it's going to do this math and then print out the result. So 3 plus 3 is 6, so the first line prints out 6. Then 3 minus 3 is 0, so the second line prints out 0. 3 times 3 is 9, so it then prints 9. And 3 divided by 3 is 1, so the last line prints 1. And in order to separate this hello world from this math, just so it's easier to see in the terminal, I'm going to do a blank print statement. So I can just do 2 quotation marks with nothing in them, and it'll just print an empty line. So if I run this again, now there's an empty line between hello world and the math, so it just kind of better organizes the output and makes it easier to see everything. Alright, so now we can try doing some math with decimals. So if we do system.out.println, we can do 2.5 times 3.6. We can even use decimals. So now it's going to print out the product of those 2 decimal numbers, which is 9. So it prints 9.0. And then, as it said on the slide, we can use more complex calculations using the order of operations. So we could do 3 plus 5 times 10 minus 2, which should result in 51. And we could also do the same thing, but put parentheses around the 10 and the 2. So now, according to the order of operations, the subtraction will be done before the multiplication. So the result would instead be 43. And if we run this, oh, I forgot a semicolon. Yeah, so VS Code will tell me that the build failed because I made a mistake. Every line of a statement of code needs to end with a semicolon. So if I run it this time, we have 51 and 43. So it's the same numbers, but since we added parentheses, the math was evaluated in a different order, just like when doing math in real life, without code, or with a graphing calculator. Alright, so now we're going to talk about variables. Programs would not be useful if you had to write a separate program to perform the same calculation on a different set of numbers. So if we wanted to add a bunch of different things, but we had to make a new program for each set of numbers, that would be very time-consuming. But variables allow you to make your programs much more flexible. In Java, the variable must be created before it can be used. The programmer must also specify the type of data that the variable will represent. So here we have two variables, number to display and increase display. And then they are being added. So after we define the variable name can be used inside the program, and the value of that variable will be used to evaluate the statement. Okay, that might be confusing, but we are going to now actually write that out. So we are using more print statements, so I'm just going to add another empty print statement with just quotation marks with nothing in them. So variables in Java are just like variables in math, except they don't have to be single letter names, and they can do a bit more, but we'll get into that a little bit later. But we can define a variable called number to display, and we're going to set the variable to 5 using the equal sign. So this equal sign is like the set operator. It's just saying that this variable is 5. So then we can do a similar thing with increase display. This is 10. So this variable is the number that's going to be printed to the console. And then increase display is the number that's going to be added to that number before it's displayed. So, or actually it's displayed twice, but that's fine. If we print out number to display, it's going to print out the value. So it's not going to print out the words or the characters number to display, but it's going to print the value of the variable. And then we can also use arithmetic on variables. So we can do number to display plus increase display. So it's now increasing the number that's being displayed. Now, I would like you to pause for a second and think about what's going to be printed to the terminal from these two print statements. Now we'll see if you were correct. If we run this, it prints out 5, so this first one is printing 5, and the next one is printing 15. So rather than printing out these letters, it prints out the value that was assigned to this variable. So when we write the name of the variable, Java will evaluate it as its value. So it prints out 5 because that's what we set this variable to. And then number to display plus increase display is the same as saying 5 plus 10. So let's break it down a little further. An int is the type of variable that we wish to declare. Num to display is the name of the variable, and equals 5 means assign the value of 5 to the variable. So int being the type, what is an int? Int variables can store integers, as its name suggests, like 1, 3, 2000, -1, or -234323. Java has other variable types for different types of data. So that's the main distinction between variables in math and variables in programming. In math, variables can only be numbers, but in programming, variables can be values other than numbers as well, depending on the data type. But for ints, they only store integers. So for number variables, we have the following types: int for integers, as was just explained, double for decimal numbers like 1.0, 3.0, or -2.35. Doubles store up to 15 digits. Floats are essentially the same thing. They're also decimal numbers, but it's rounded after 7 digits. So a float is a decimal number that can store up to 7 digits, and a double can hold double that amount of digits. So kind of makes sense. Well, it's almost double. It's almost double. Slightly confusing, but it also makes sense. Anyway, as for text, we have char, which holds single characters like A, J, or B, and they can be uppercase or lowercase. It can also hold like symbols and digits as well. As long as it's a single character, a char will hold it. String, on the other hand, will hold strings of characters, so they hold more than one character. So hello world was an example of a string. And once again, strings, like chars, can also hold symbols or numbers. All of these data types are primitives, which means that they are predefined in Java or native to Java, except for the string. So these data types are the most basic forms of data in Java, except for the string. So we'll learn a little bit more about how strings are different from other data types, but it's very useful to know that a string is not a primitive type, and these are. So these are all native to Java. So after you declare the type of variable, you need to give it a name that you will use to refer to it. So in our case, we used num to display after saying that it was going to be an integer, and then we set its value to 5. So the name of the variable must be unique from other variables. So that seems kind of obvious, right? You can't have two variables with the same name, because, you know, then Java will not know which one that you're referring to. There are also some other rules and limitations on how you can name a variable, and we'll talk about those later. The equals operator, the equal sign, which is actually the set operator, is used to assign a value to the variable. And then that value is substituted anytime the variable is used inside of the program. So again, we saw that in our program when we wrote the word num to display. It evaluated that as 5 because 5 is the number we set that variable to. Assigning an initial value is called initialization. So when we said num to display is 5, that was initializing it because you gave it an initial value. All number values for int and double are entered as is, while any text values for char or string are entered using quotation marks. So for char, we use single quotation marks, and that's an example. But for string, we use double quotes, and here's another example. So we have example instantiation here. Int myInt is 5, so that creates an integer called myInt with a value of 5. This is creating a double, a decimal number called mydouble, which has a value of 6.0. Then this is making a char, a single character called yes or no, with the value of y, and you see the single quotes. And then this one is making a string of characters called mySentence, and it's set to hello world. So if you also notice in our print statements, when we were printing text, we had to surround it with quotation marks. But when we were printing math equations, we did not use quotation marks because these were going to evaluate to an int or a double. This one was evaluating to a double. These ones were evaluating to ints. If we did put quotation marks around these, they would print out literally 3 plus 3 instead of printing out 6, because this is now a string instead of an int. So if I were to run that now, you can see that it just printed 3 plus 3 instead of printing 6. But we don't want that, so I'm going to get rid of the quotation marks. Okay, so after declaring the variable, you can then use it in your program anywhere you're allowed to use that type of data. Java automatically knows that name is now a variable, so you don't need any special brackets or quotations to use the variable in your program. So some more examples. If you created mySentence as a string, you can print out mySentence and it'll print the value. So here mySentence was set to hello world. So if you wrote system.out.println mySentence, the terminal will say hello world. And then mydouble times myInt will result in a number. Since you're using two different types of data, Java just is going to assume that the result is a double in this case, so it'll print out a double. Now more about variable names. The name of a variable or other item, class, method, object, etc., defined in a program is called an identifier. So we talked about how the class was named myFirstProgram and the main method is named main. We don't know what an object is yet, but we will in future lessons. So all of these names are identifiers. We also mentioned that there are some restrictions, so we're going to talk about that now. The name of a Java identifier may include letters, digits, or the underscore symbol, but it must not start with a digit. Identifiers can theoretically be of any length, but you don't want them to be too long because that's just gross. You want to maintain clean code, and there are lots of conventions for how you should name variables. You should be specific, but you should also be concise. But when it comes to our team, I think we favor being specific over being concise. But just make sure you're not making long novels out of variable names. Java is case sensitive, so rate with a capital R, rate with lowercase r, and rate in all caps can all be used for 3 different variables. These are not evaluated as the same name because, again, Java is case sensitive. But it's probably not a good idea to make 3 variables with the same name with different capitalization because that just gets confusing. So that just comes back to convention and clean code. Just because you can do it doesn't mean you should do it. So you should probably think of 3 different names for these variables instead of naming them the same thing with varying capitalization. There are some cases in which it makes sense to use the same name for 2 variables, but most of the time you won't want to. Lastly, you cannot use the same identifier to define multiple variables in the same scope. So again, you can't name a variable something that another variable is named if it's in the same scope. Now, we're going to talk more about what a scope is later, but basically there are these sort of areas of code called scopes where this matters. So in our main method, for example, that's one scope, but we'll talk about it later. Just for now, know that in the main method, you won't be able to define 2 different variables with the same name. Now, on this team, we follow the general Java naming convention used by a majority of programmers worldwide. We also have decided to adhere to the rules in Google's Java style guide for the most part. So their style guide is available online. I might link it in the description. And if you are on our team, it's also in the Google Classroom. So it's available. It's good to look through, a very good resource. And that's why we try to adhere to it. So make sure to start the names of variables and methods with a lowercase letter. So we did this with the variables we've made so far. Num to display begins with a lowercase n, but then new words in the name begin with an uppercase letter. So the T in to and the D in display were uppercase. This sort of naming is called camel case. So again, for variables and methods, we use camel case. All remaining characters must be digits and lowercase letters, so you wouldn't have 2 capital letters next to each other. We also use whole words and abbreviate only when it's clear on what the variable is for. So again, with making code easy to read, you don't want a variable name where no one knows what it means, because that will just lead to trouble. Here are some example variable names. We have top speed with lowercase t, capital S, bank rate 1, same thing, it's in camel case, and time of arrival. Start the names of classes with an uppercase letter, so the file name as well as the name of the class, since they are the same, begin with an uppercase. So in the file My First Program, M is uppercase. Otherwise, adhere to the rules above. So it's very similar to camel case. I believe it's called upper camel case, but yeah, same thing, just the first letter is uppercase instead of lowercase. So more example names, First Program, and My Class. Then, as a reminder, Java won't accept a name that starts with a number, and the name cannot contain any symbol other than underscores. Now, more convention. Be specific and unambiguous in your variable names. Anyone else looking at your code should be able to understand what your variables are at a glance. So, for example, a variable containing the maximum speed of a wheel should be called something like max wheel speed, and it should not be called number, x, dog, or simply speed. One more thing about variables. You don't always have to assign a value to the variable immediately. Writing the below statement is perfectly legal for any type. So you can write int age and then not declare it, not initialize it, so you're not giving it an initial value. Then write some more code, and then later on you can put the initialization and assign it a number. As you can see, we did not specify the value at the same time as when we declared the variable. This is called declaring an uninitialized variable. It means we declared it, but did not assign it a beginning value. There are perfectly legitimate reasons to declare an uninitialized variable, but avoid doing so if you can. So, if you try to use a variable that doesn't have a value yet because you didn't assign it one at first and you forgot, or the code is written somewhat incorrectly, you'll get an error in the code and it'll be a null pointer exception, which just means you're trying to access a value that doesn't actually exist. So in general, it's better to just assign it a value like 0 than to risk getting errors in your code for trying to use something that doesn't have a value. If you don't know what the value should be, then just initialize it to 0 for numbers or blank text for characters and strings. Alright, so now we're going to talk about variable assignments. So now that we have variables, we can use them in our program. The program can even change the value of a variable, which is extremely helpful. So obviously variables, as their name suggests, are variable. Their values can change, and yeah, that makes them very useful. So in Java, we use the equal sign, which is the assignment operator to assign a value to a variable. We already saw that when we were initializing them, but it still holds true after we've already initialized them. So we're now going to write this back in my first program. So down here, we'll make an integer called num of cookies. And then we'll set it to 5. And then this is an example of variable declaration and initialization. So just as a reminder, declaration is declaring the type and the name, which is just saying, I'm going to create this variable, so reserve some space for it. And the initialization is when you actually assign it the initial value. They can either be on the same line or they can be on separate lines. The next line is just going to be to print out the num of cookies. And that being said, I'll add another blank print statement just to separate this from everything else. And then we'll say, I just baked 10 more cookies. So we'll do num of cookies is now 15. And we'll then print out the new number of cookies. And then right here, I'm going to add a comment that says, changes the value of the variable. All right. So let's break this code down. In the first line, we declared a new int variable with the identifier num of cookies. We then assign it a value of 5 using the assignment operator, the equal sign. So again, we are making an integer called num of cookies that is being set to 5. We then print to the screen the value of a variable, and then we say that we baked 10 more cookies. So the number is printed to the console, and then the text, I just baked 10 more cookies, is also printed to the terminal. So then, using the assignment operator, the equal sign, we change the value of our variable to another integer inside the program. We don't need to use the int keyword again because we already have defined it as an int above. So since we declared it already, we don't need to specify that it's an int. So instead of saying int num of cookies is 15, we just say num of cookies is 15. So in Java, the assignment operator is used to change the value of a variable. As we've said, an assignment statement consists of a variable on the left side and an expression on the right side. An expression can consist of any mix of variables, numbers, operators, or method invocations. So we still don't exactly know what a method is, but we will talk about that later. So here are some examples of assigning variables. So if we have a variable called temperature that we already declared, we can set it to 98.6. If we have a variable called count, we can set it to the value of another variable. And if we have a variable called formula, we can set it to an expression that has arithmetic using numbers and also using a variable. So assignments can become pretty complex, and expressions themselves can be pretty complex, even just using what little we have learned so far. So again, this is just going to evaluate as whatever value temperature has, and same here. Alright, so now we're going to put it all together. So let's write a program which calculates the circumference of a circle of any radius and then prints the result to the screen. So we're going to make a new program called circumference. So go back to VS Code, and over here in our folder, I'm going to make a new file called circumference. And remember that we should make it begin with a capital letter, and also that we need to add .java so that it knows it's a Java file. And VS Code will add this class definition for us so we don't have to, which is nifty. And again, capital C, and it has the same name as the file. So the first thing, we need to add a main method. This is a separate program, so we need it to have its own main method. So public static void main, open parentheses, string with the brackets, args, and then open curly bracket, and then inside the main method is where the code goes that's going to be executed. So if we are calculating the circumference of a circle, the first thing we probably want to know is pi. So we're just going to add pi, or we're going to create a variable called pi. That way it's a lot easier, so if we ever need to use it more than once, we don't have to write out the full number. So I'm going to say double pi, and it's a double because it's a decimal. And then it's equal to 3.14159. And And then we also need to know the radius. So double radius. And we'll say that the circle is a circle with a radius of 5. And the units can be whatever you want them to be. It's 5 units. So then we'll want to create a variable for the circumference. So it's a double, again, because it might be a decimal, probably will be, and it's going to be called circumference. And then, again, we can set variables to expressions. So I'm going to want to set this to the formula for calculating circumference. So that would be 2 pi r. So we're going to do 2 times our variable pi, oh, but we want a space there, times the radius. So 2 pi r. And then we can print this out so that we know what it is. System.out.println circumference. And then remember to add the semicolon, and then we can save and run the program. And then here you can see the circumference is 31.4 units. So you should be able to change the radius to be able to calculate the circumference for a different size circle. So here we can see that if we change it to a different number, we'll get a slightly different circumference. So we know that the program is working, and that's it for our circumference program. Let's go back to the slides. Alright, so now we're going to talk about constants. If you've taken a math class, you probably know what a constant is. It's just a number that remains constant. So in your graph formulas, y equals mx plus b, b would be the constant, m would be a constant. It's just a number that's not going to change. So there's a problem with the program that we just wrote. The number pi in the real world never changes. Pi is always 3.14159, etc. However, nothing in the program prevents us from changing the value of pi. In a really big program, we might accidentally change the variable by accident later on in the code. So, for example, we can do this unintentionally. We could set and initialize it at the top, and then add a bunch more code, and then later on reassign the value. And we don't want to be able to do that, because after that, anywhere we use pi, the resulting calculation will be incorrect because we've used 3 instead of the decimal, and this might be really hard to detect. We can prevent this from happening by making pi a constant. So we use the final keyword to tell Java we never want to allow the value to change after we declare it. If we try to change the value, the compiler will throw an error and alert us of the problem. So if we go to VS Code, we will want to change pi to a constant by using the final keyword. We also have different naming convention for constants. We name them in all capital letters, and different words are separated by underscores. So I'm going to change the name of pi now that it's a constant. So make sure you do that, and then if I try to set pi to something else, as the slide said, it's going to give me an error. It says the final local variable pi cannot be assigned, so it's a constant, so it's not going to let me reassign it. And that is a very good thing. So once again, the keyword final is what makes a variable into a constant. And you'll always want to use a constant when you want to be sure the value doesn't change after you set it. So now here's a slide about those naming conventions I was talking about. When we declare a constant using the final keyword, we follow a different naming convention for the identifier. Use all capital letters, any words are separated with an underscore, and do not use arbitrary abbreviations. So down here are examples. We have my name in all capital letters and separated by an underscore. We have my age, num of days per week, pi, and pennies per dollar. So now that we know about constants, let's fix the solution. We already did, but this is fine. Remember that Java is case sensitive, so you can't make the constant pi but then try to call it pi. So yeah, if we go back to the code and I try to call it like that, it's going to tell me that pi cannot be resolved to a variable because a variable with this name does not exist. It's pi with capital letters. Alright, so now we're going to talk more about the plus operator because it can actually be used for more than just addition. So we previously learned that the equal sign is the assignment operator, or the set operator as I like to call it. Well, the plus operator has a special function in Java as well. The plus operator can be used for addition in math equations such as 5 plus 6 times 9, as we have seen, but it can also be used to add strings together. So here we have string text 1, my name is Kevin, and then string text 2, and I'm an aluminum falcon. So then we can set text 3 to text 1 plus text 2. And we're going to write that down to see what the result is. So back to my first program, and we'll add another blank print statement. And then just like we saw, we'll do string text 1, and it's my name is Kevin, and then string text 2, and I am an aluminum falcon. So then text 3 is going to be text 1 plus text 2, and we're going to print text 3. So we now can run this. And once we do, we can see that these two strings were put together into one line, So that's what adding them did. It created one string that was just this string connected to this one. But as you can see, there's no additional space here, so it's grammatically incorrect, but it is pretty useful to be able to add different strings together when you want to make sentences like this. So we can fix the sentence by adding a space between both sentences. Simply putting a space between quotation marks allows us to combine the strings properly by adding that additional space between the two strings of text. So combining strings like this is called concatenation. Now we can go do what it suggested and just add that space. So now when we run this, there's an additional space concatenated between these two strings. So my name is Kevin, space, and I'm an aluminum falcon. You also could add a space to the end of the first sentence or the beginning of the second one, but there might be situations where you can't do that with variables, so you would just have to add the space here by concatenating it along with these other two strings. We can also use the plus operator to combine a string and a variable name, or a variable we are printing. So you could do my name is, and then if you have a variable called my name, it would print the value of that. So if my name was set to Kevin, then this would end up printing my name is Kevin. So putting this all together, using concatenation, we can create better programs. So back to circumference, we can use this concatenation to print out a sentence instead of just printing out this mysterious number when we might not know what it means. So instead of just printing out circumference, we instead can say the circumference of a circle with a radius of, and then we'll concatenate radius. So in this case, it'll say a radius of 6, but if we change it, then it'll change what it prints. Is, and then we can concatenate the circumference. So when we run this, it says the circumference of a circle with a radius of 6 is 37.699, etc. And, you know, as usual, if we change the value of this variable, everything else changes, so the circumference is going to change, and what this prints out is going to change. So if the radius is 3, it'll say the circumference of a circle with a radius of 3 is 18.8. Now this line is a pretty long one, so we can actually make it a multi-line statement. So after radius, if we press enter, it'll still run, and then we want to indent one more time. So when we have multi-line statements like this, we want to use a hanging indent, so every consecutive line is indented one more level from the top level line. So we can add a comment here. One statement can span multiple lines. And when we run it, we can see that it still runs the same. So using 2 lines doesn't make a difference. The way that Java knows that this statement is over is with the semicolon, not with the end of the line. So that's why we use semicolons. And theoretically, you could put every letter on its own line. Or maybe not. But that would be very gross, so you want to keep everything together. For the most part. You don't want to split it up too much. We're now going to talk about arrays. Let's say we want to group similar variables together. We can do so using an array. Arrays are another data type in Java. They store other like-typed variables. You can think of an array as a list or a box of other variables. For instance, an array of strings stores multiple strings, while an array of ints stores multiple ints. The values within an array each have an index number. So the important thing to note here is that they store like-typed variables. As you might be able to tell from these examples, you can't have an array with multiple different types of variables within it. So you wouldn't be able to have an array with strings and ints, or ints and doubles. You can only have an array with all strings, or all ints, or all doubles, etc. So we're going to go back into myfirstprogram.java and create some arrays. First, we're going to write int, but we want to add square brackets after the word int, and then we're going to call it even numbers. And then we'll use the assignment operator and use curly brackets. Then we can put 0, 2, 4, 6, 8, and that should be enough. Then end it with a semicolon. Then let's say we want an array of strings. We'll put string with square brackets, and we'll call this groceries. So this is going to be a grocery list. Again, we'll use curly brackets, and then we'll say apple and bread. So let's break it down. In the first line, we create an array of 5 ints. The curly brackets denote the start and end of the array, and each value within the array is separated by a comma. Thus, this array is a list of the numbers 0, 2, 4, 6, and 8. The second line is very similar. We create an array of 2 strings. So in this case, groceries is a list of the string apple and the string bread. You'll see that the notation with the curly brackets is similar to how we use them to wrap around the method body or the class body. With strings of longer, or with arrays of longer numbers or strings, sometimes people will kind of format them similarly to methods or classes, where you press enter after the curly brackets, and then maybe there's a new line for each item in the list. But since these are really small lists with really small items, we don't need to do that. But that's just another example of how you can use multi-line statements in Java. So we can access an item from an array by writing the array's name followed by square brackets containing the value's index number. So in this case, we have a print statement that's printing the 0th value within even numbers. So we can go back to the VS Code and write that out. System.out.println, even numbers, square brackets, and then 0. So this is getting the number within this array with an index of 0. So if we run this, it's printing out 0. This value right here. So each value within an array is given an index number, just like in a numbered list. So if we had a text file called grocerylist.txt, we would make a list of all of the groceries we want. So number 1 would be apple, number 2 would be bread, 3 would be milk, 4 could be cheese. And so an array of strings called grocery list would be very similar, where you have apple, bread, milk, and cheese, and all of these values are given a number, just like these have numbers in a numbered list. But it's worth noting that array indexes start from 0. So within programming, it's convention to start counting from 0 instead of counting from 1. So you'll see that in a lot of places. But for now, just know that we start counting from 0. So the apple is index 0, bread is index 1, milk is index 2, and cheese is index 3. So writing this line will print out the value within even numbers that has an index of 0. That would be the first value in the list. In this case, the value that is printed is 0, so we saw that when I printed it just earlier. In this way, you can use the items within arrays just like any other variable. So first, I'll just give an example with the grocery list. Just like you saw on the slides, if I print groceries with an index of 1, it's going to print out the grocery at the first index. So pause the video and think about what this is going to print. Is it going to print apple? Is it going to print bread? Or is it going to print something else? If we run it, we'll see that it prints bread. So bread is the value at the first index because apple is at the 0th index. Now we can end up using this in expressions, again, just like any other variable. So I could do system.out.println and then use this in arithmetic. So I could do even numbers with an index of 2. So that would be 4, 0, 1, 2, plus even numbers with an index of 4, 0, 1, 2, 3, 4. So that's going to give me 8. So it'll be 4 plus 8. Similarly, we could do concatenation with the groceries. So I'm going to add ln. And then let's say I'm going to the store to buy, and then we're going to list off everything we're going to buy. So the first thing is an apple. So we can do groceries and then index of 0. But we need the plus operator so that we can concatenate it or add these values together within a string. So I'm going to buy an apple and some bread, which would be groceries. And then what do you think I'm going to put within these square brackets? I'm going to put the number 1 because bread is at the 1 index of this array. So if I run this, the value of this is 12 because it's 8 plus 4. And this ends up printing just like I had said. I'm going to the store to buy an apple and some bread. So arrays can be used just like any other variable. The values within them specifically can be used like any other variable within expressions or arithmetic, etc. Alright, now we can talk about branching with the if statement. So we can make decisions in programs using the if statement. Let's go back to my first program. We are going to add a double called x. So double x, and we're going to say it's 10. So now we'll write if, and then open parentheses, x is less than 10, so less than sign, and then curly brackets, system dot out dot println hello world. And then underneath that, I'm just going to say system.out.println goodbye world. And then above this, I'm going to add another blank print statement. So let's break what we just wrote down. If is a Java reserved word, so it's a keyword. It's a word that has special meaning in Java, just like int or double or class. The condition must be a Boolean expression. So within the parentheses is the condition of the statement, if this. So it's a Boolean expression, which means that it evaluates to either true or false. If this is true, then do this. So if the condition is true, the statement is executed. If it is false, the statement is skipped. So let's say you just wrote the word true there, that would work. If true, statement. So since true is true, it would execute whatever's here. If you wrote the word false, false is false, so it would skip this. It would not execute whatever is in the if statement. Alright, so let's actually go back for a second. So this right here is like a conditional statement, x is less than 10. So with that, think about what will be printed if we run this code. What is going to happen? Well, if we run, it doesn't print hello world, but it does print goodbye world. So this right here is the condition. X is less than 10. So if X being less than 10 is true, it would print hello world, but it didn't print that, so we know it was false. Well, X is 10, as we see here, we set it to 10, so X being less than 10 is false, which is why it skipped this. If we were to set X to 9 or any other number that's less than 10, it would print hello world. And it doesn't want to run. It would print it, and it does. Goodbye world is outside of the if statement, so it's going to run no matter what. So again, this is just saying if whatever's in here is true, do this. Or in this case, if X is less than 10, print hello world. So the compound statement, if the statement under if is made up of more than one statement, so like here you can see there are multiple statements, they must be enclosed in curly brackets. If it's only one line, you don't have to use curly brackets. So I could remove these since this print statement is just one line. But if there are multiple statements, Java needs a way of knowing that all of these statements fall under the if statement, so that's when you would need to use curly brackets. If there's only one statement, it's optional, but if there are multiple, like in this example, you absolutely need to have the curly brackets so Java knows that all of these fall under the if statement. So let's try that out. You'll make an integer called amount, and it's going to be 32. Then another int called balance, which is 49. If the amount is less than the balance, then let's just say the person is trying to withdraw money from the bank, so the amount they want to withdraw is less than their balance. They can withdraw. So we'll print thank you, withdrawal will take place. I don't, okay. So then we would say balance is balance minus amount. So it's just going to subtract amount from its current value. So you can do that. You can call this variable like within the expression that you're assigning it to. So this is going to say that balance is now 49 minus 32. And then you can say balance is now, and then concatenate balance. And then we can say, have a nice day. Alright, so since this is multiple statements, it needs to be within the curly brackets here. Here it says that any statements inside of the brackets under the if will be executed whenever the condition of the if statement is true. So let's see if this runs. Make your guess as to whether these statements will be printed or executed. As you can see, when we run it, they are indeed executed. It says thank you, withdrawal will take place, and then it changes the balance and says have a nice day. So amount is in fact less than balance, 32 is less than 49, so all three of these statements end up being executed. That is all for lesson 1. Hopefully that was easy to understand, and hopefully you learned a lot. If you are someone from our team learning how to teach this, hopefully that was helpful. Definitely ask open-ended questions to the students you're teaching. And I hope that you watch lesson 2. There will be a lab video for this, a sort of review quiz, and then a lab to go along with it to help reinforce what was learned. So once that is posted, I'll probably put a link in the description. There will be a lot of links in the description. So check the description and have a nice day. Thank you.